What is 5G? 5G is the fifth generation of wireless network technology standard for broadband cellular networks, which cellular phone companies began deploying worldwide in 2019, and is the planned successor to the 4G networks, which provides connectivity to the most current cell phones. 5G networks will provide 50 times more speed, 10 times less latency, and 1000 times more capacity than 4G/LTE. This means 5G will be able to connect to more devices and transmit more data than ever before, delivering fast connectivity and significantly enhanced user experience. 5G internet utilizes millimeter waves for advanced transfer speed. To do that, more small cell towers are required for wider cover range for the millimeter wave. This technology can be known as a massive MIMO. It increases the antennas, which will improve throughput and network efficiency. However, the increase in cell towers also increases the interference. Therefore, beam forming is applied and used to solve this issue. Beam forming triangulates signals in a way that packets move are controlled to improve throughput and latency. Beam forming allows radio signal to be directly transmitted towards the receiver instead of the transmitting in all directions. 5G is the current generation of wireless cellular technology. It provides massive level of performance and efficiency over the present technology. The new technology discovered through 5G are as follows. First, millimeter waves. Millimeter waves are extremely high band frequency wave of the electromagnetic spectrum. They lie within the frequency range of 30 to 300 GHz. Millimeter wave expands the spectrum, and since they are less congested compared to the other broadband connections, due to this, it facilitates high-speed transmission rates. On the contrary, the disadvantages associated to millimeter waves are vulnerable, susceptible to interference from nearby electric poles, cellular towers. Therefore, the movement of waves are affected by obstacles such as building, trees, and requires line of sight, non-barrier for transmission to resume. Secondly, we have small cells. Issues faced by millimeter waves are rectified by small cells. Small cells are miniature, low-powered wireless base stations to cover a small segment in a macro areas. They monitor the quality of network, enhance network capacity and coverage. Application for smart pods is by placing this small cell every 250 meters within the pod, which prevents signal from being blocked by ship's physical obstructions. Small cell accept signals from other base stations and transmit data at a large data rates. Thirdly, we have massive MIMO, multiple input output. MIMO is massive, which is important in a 5G network deployment. It increases antenna, which improves throughput and network efficiency. This allows for smart pods to receive greater amount of data from equipment in smart pods like remote cranes, surveillance, and automated guided vehicles. Massive MIMO increase spectrum efficiency. However, the increase in cell towers increases interference. Beamforming is used to solve this. Beamforming triangulates signal in a way that packets move are controlled to improve throughput and latency. Beamforming allows radio signals to be direct transmitted towards the receiver instead of transmitting in all directions.
Okay, let's talk about smart pods. Smart pods are predicted to be the future of the shipping industry. These pods implement innovative technologies to enhance performance through artificial intelligence, big data, Internet of Things, blockchain technology, and cloud computing. It will enable pods to derive actionable insights from the data collected. 5G will further enhance the adoption of Internet of Things. It also embracing digitalization and automation to maximize efficiency and collaboration. A smart pod equips the workforce with relevant skills and technology to solve the unique internal and external challenges of the organization and to facilitate the efficient movement of goods, delivery of services, and smooth flow of information. Using a holistic approach, the smart pod achieves results without creating new challenges internally or elsewhere in the supply chain ecosystem. The smart pod minimizes the negative impacts of its activities on the natural environment and enhances the surrounding communities, especially economically and socially. The material benefits of chosen technologies allow the smart pod to improve efficiency to gain competitive advantage, increase business resilience to economic shocks or disruptive forces, extract maximum value from physical assets, develop new revenue streams based on digital value propositions, increase employee engagement and well-being, and also achieve and exceed environmental commitments.
So now let's talk about the challenges faced by traditional ports. The first challenge is port infrastructure. The second one is global trade. The third challenge is production capacity. The fourth challenge is finances, followed by the fifth challenge, which is regulation and compliance. The sixth challenge is safety and security, followed by sustainability and digitalization, and last but not least, community support. Let's talk about how Smart Port solves this issue. The first challenge just now was port infrastructure. So how Smart Port solves this issue is that the infrastructure must change to keep up with the transport industry. A smart port strategy for infrastructure incorporates the idea that residents, the community, and the port ecosystem are included into the port infrastructure. Thus, this helps with the port infrastructure, since this enables co-operation predictions that will affect other stakeholders. The second challenge is global trade, and how Smart Port solves this issue is that the Smart Port strategy helps ports to better accommodate growing vessel fleets in the maritime industry, since technologies can instantaneously track vessel locations. And this helps the port to better accommodate growing vessels fleets. The third challenge was production capacity, and how smart ports can help to solve this issue is that smart ports use key technologies to be more efficient. By being more efficient, they can handle higher capacity and serve a higher demand. The fourth is finance, and how smart port helps to solve finance issues is that smart ports help to operate at full capacity by providing supply chain transparency. For example, with the help of a real-time digital dashboard, port authorities can see all the activities in a port, which allows for better planning. The fifth challenge was regulation compliance, and how a smart port project solves regulation compliance problem is that there is an idea that smart ports encompass care for the environment. Strategies involve monitoring environmental key indicators to ensure compliance and avoid fines. The sixth challenge was safety and security, and how a smart port project solves safety and security problem is that smart port technologies with the use of artificial intelligence (AI) enable heavy port machinery to be automated. This means that employees who once used to work manually with dangerous machinery instead control it from large towers. This also allows the employees to be more efficient with other tasks, and human-related disruptions are less likely to be an issue. Seventh issue was sustainability, and how SmartPort helps to solve this issue is by implementing a large part of SmartPort into the digital era, but it also incorporates going green. With the use of advanced technologies, ports are adopting new forms of energy. Strategies can include developing green energy resources, that can even provide green energy to entire smart port city complexes, for example, offshore wind farms. The eighth issue at hand was digitalization, and how SmartPort helps solve this issue is that SmartPorts are essentially digital. Therefore, by becoming a SmartPort, new technology solutions can be integrated into the organization, which involves autonomous cranes and vehicles, advanced analytics, shared dashboards, real-time data, digital twins, enhanced maintenances, accurate predictions, and new digital solutions. The final challenge was community support. And how SmartPort helps to solve this issue is that with the SmartPort philosophy, the community is integrated back into port operations. They consider how they affect the community by focusing on developing the attractivity of their ports for residents and tourists, caring more for the environment, and providing jobs for surrounding residents.
Changes at the core level are among the myriad of architectural changes that accompany the shift from 4G to 5G, including the migration to millimeter wave, massive MIMO, network slicing, and essentially every other element of the diverse 5G ecosystem. 5G standalone mode is essentially 5G deployment from the ground up with the new core architecture and full deployment of all 5G hardware, features, and functionality. As non-standalone mode gradually give way to all new 5G mobile network architecture, deployments, careful planning, and implementation will make this transition seamless for the user base. 5G implementation brings some performance benefits and diversity of application through extensive use of cloud-based resources, virtualization, network slicing, and other technologies. Security in 5G architecture brings best practices include end-to-end 5G network security monitoring, encompassing the system architecture, device, and apps. It also improves 5G security features detailed by the 3GPP standards include unified authentication to decouple authentication from access point and public key-based encryption schemes to reduce the risk of metadata exploits. It also continues monitoring and assessment of security effectiveness are essential as 5G critical performance nodes become increasingly virtualized. Undoubtedly, 5G is delivering the exponential speed enhances users that have come to expect with a new generation of mobile networks, but the speed is just the beginning. The changes to industry ranging from personal transportation to manufacturing and farming are so significant that many have dubbed 5G the next industry revolution.
So, what are the computer network concepts that can be implemented in this process? Those are TCP and UDP hybrid, network slicing and redundancy, and device-to-device connections. TCP and UDP hybrid. These protocols are used to maximize the usage of 5G. The TCP and UDP protocols are used to ensure a real-time low latency and stable connection, which is achieved in automation with TCP and UDP hybrid devices, which can offer a fast transmission speed by using UDP while maintaining reliability using the congestion control feature of TCP. Firstly, once the connection is established between the client and the server, the client sends a request to the server using the hybrid TCP and UDP protocols. The server will then decide whether to use this TCP or UDP. To ensure the packet are received by the client will send acknowledgement packet in a fixed time duration. If there's a packet loss, the client will send acknowledgement to the server, and then the server will use TCP protocol for retransmission and perform a congestion control. Network redundancy and network slicing. Network redundancy and network slicing are used to prevent network traffic in 5G. Network redundancy provides network availability where the data can be redirected to the other redundant network links. As a result, the data transmission will not be disrupted because of the network links or component failure. Network slicing enables service providers to create end-to-end networks for different application requirements. So how does the network redundancy prevent network traffic? There are a few physical connections between the sender and the receiver. The data transmission from the sender to the receiver. When one node is damaged, the data transmission will be redirected to another part in order to reach the receiver. 5G enables device-to-device communication, which is better than peer-to-peer connection, and client-server networks. Device-to-device communication refers to a radio technology that enables devices to communicate directly with each other without routing the data paths to network infrastructure such as cell towers and small cell space stations.
So how does the changes in architecture of network for 5G relate to what 5G can do for smart pods? First is intelligent automation, grouped as massive machine type communications (MMTC) in the service layer. It deals with the intelligent controlling and monitoring of the end devices with the combination of physical entities and application services. The efficiency of the pod can be achieved by improving the automation, which will also help to communicate between the different parties present on the pod. Smart ships are equipped with sensors in order to monitor the position of the ships and environmental data in real time. Containers can also be equipped with sensors to monitor the temperature and to trace their location. Next is virtual reality, which is the network slice of enhanced mobile broadband (eMBB). It allows the field operator to work efficiently by allowing them to monitor the pod operations in real time via video surveillance, and also enables them to visit the pod in a VR environment and to receive remote assistance. It requires higher throughput and a reliable connection, which can be achieved by deploying 5G network architecture. Finally, smart guided vehicles, which is the network slice of ultra reliable low latency communications (URLLC). Conventional trucks can be replaced with smart guided vehicles in order to improve the safety and pod efficiency due to their ability to consume less resources. SGV needs to be equipped with sensors and high resolution cameras, so the existing 4G network cannot meet low latency requirements of SGV, but it can be achieved by the 5G network.